Thank you for joining this lesson. We're going to study statistics. The table below shows the masses measured to the nearest kilogram of 200 people. Therefore, we have the masses in classes, then we have the number of people, or rather the frequencies for each respective class. Draw a cumulative frequency curve for the data above. So the data above, which is in classes, for us to draw cumulative frequency curve, it should be known that this is also called the Ogive. The first thing to do in this case is to draw, or rather to come up with the cumulative frequency column. So cumulative frequencies can be given their own column here. The first class, we have 9. Then we had 27, and we're going to get 36. We add 70, we get 106. We add 50, we get 156. We add 26, we're going to get 182. Then when we add 12, we shall get 194. And finally 200, because we've been told for 200 people. So these are the cumulative frequencies for each class. Now it should be noted that for cumulative frequency curves, we plot cumulative frequency against what we call the upper class boundaries of each class. And that is what we're going to do right now. So we're going to come up with a cumulative frequency curve, or rather an Ogive, the Ogive. Then we respond to a few questions from the same graph. So I'm going to draw the graph here. This one is my vertical axis, which will contain the cumulative frequencies. Then now I have my horizontal axis here, which is going to contain the upper class boundaries. The upper class boundaries, or rather the class boundaries, because upper class boundaries automatically become lower class boundaries for the preceding class. Therefore, now I'm going to start by first of all checking this data. We can see that the least lower class boundary is going to be 39.5. And 39.5 to 49.5, we have an interval of 5. So when we use intervals of 5 for one big square, we are not going to start from 0, because when we start from 0, then we shall have from 0 to 39.5 being vacant on the scale. Therefore, it's advisable on the x-axis, the class or the axis which is going to contain the masses, because we will have the masses here in kilograms. We break the axis and we begin from 39.5. So that now we go to 49.5. Yeah, we go to 49.5. Therefore 49.5. Then after 49.5, we can add 5 again to 54.5. Then we add 5 to 59.5, 64.5, 69.5, 74.5, 79.5, 84.5, and 89.5, the 94.5, and 99.5. Let me check the highest. The highest, we're going up to 109. Yeah, so we can still continue. This is going to be 104.5, then 109.5, the last upper boundary. Then now for the frequencies, we are ranging from 9 to 200. We can use intervals of 10. Intervals of 10, let me check. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Intervals of 10 will not accommodate this data. Therefore, we can use from 0. From 0, we can go to 20. So let me use 20. 40, 60, 80, 100, 120, then 140, 160, 180, and 200, 220. Yeah, that scale now is going to be accommodative according to the data provided. So we're going to plot the first upper boundary, which is 49.5 against 9. 49.5, 49.5 against 9. So this one, at the mid here we have 10. So if that is 10, it means, we have to know that 5 small squares in this case, 5 small squares represent 20 units. So one small square is going to represent 20 out of 5, which is 4. 20 out of 5, which is 4, yeah? So now each small square is representing 4. So we will have 4, 8, and because 10 is somewhere in the mid, the 9 is also somewhere just before the mid. So that is where we're going to have the first coordinate. The next one is 59.5 and 36. 59.5, 59.5 and 36. So 36 is going to be, remember this is 24, 28, 32, 36. Exactly there. The other one is going to be 69.5 and 106. 69.5, 69.5 and 106. So this is 104 and 8. So and 6 is somewhere at the center. 106. Somewhere at the center there. The other one, 79.5 and 156. 79.5. So 79.5, 79.5 and 156. So we will have 140, 44, 48, 152, 156. 156 is going to be there. Then 89.5 and 182. 89.5 and 182. 89.5 is here, 89.5 and 182. So we have 180. So this is 184. 184. So 182 is somewhere at the mid here. 182 is going to be somewhere there at the mid. 99.5 against 194. 99.5 against 194. 99.5 against 194. So 194 is going to be somewhere. 194. This is 180, remember? So if this is 180, 84, 88, 92, 96. So this is 196. That means 194 is somewhere just below 196. Just below 196. Then finally, we have 109.5 against 200. 109.5 against 200. This one is going to be exactly at this point. Therefore, now we have our dots, which are already trying to trace an ogive. So let me come up now with the ogive. Let me come up with the ogive. So the ogive, which just looks like a stretched S, is going to be drawn. Remember, the curve is going to be The curve is going to be smooth. It's supposed to be a smooth curve. We call it a continuous curve. We call it a continuous curve. So that is how our ogive is coming out. That is the ogive in this case. Therefore, now with our ogive, we can respond to a few questions here. We are told use the graph to estimate the median. So if we have a total of 200, then the median mass is going to be where half of these people will lie. Their mass is going to be, so we have 100th person is the one having the median mass. So 100th person can be traced in the cumulative frequency axis, whereby 100th person is here. And if 100th person is there, now we move with a straight ruler horizontally until we cut our axis, until we cut our graph, that is. Then now down to the other axis to read the mark, or not the mark, the mass that is represented by where we have cut the graph. So this is going to be, remember, each small square is going to represent 1 unit. Therefore 64.5, 65, 66, 67, 68.5. So that is going to be 68.5 kilograms. That will be the estimated mass according to the histogram we have. Again, we are told to find the number of people whose mass lies between 70.5 and 75.5. So 70.5, which is here. If this is 69.5, 70.5 is here. Therefore, we can read the number of people having that mass. So we use, now from this, it is now the other way around now. We start with the mass, 70.5. Then after reaching the graph now, we move horizontally again until we know the number of people having that mass. And the number of people having that mass is going to be, so that is how we read it now. The number of people is going to be, remember this is 100, so 104, 108. So we have 108 people having 70.5. Then the number of people having 75.5. 75.5. Remember this is 74.5. So 75.5 is here. So 75.5, we again do the same to establish the number of people. So we go up and now again horizontally to read the number of people, and I'm finding it is exactly 140 people. So we will have 140 people. 140 people are having 75.5 kilograms. So now the range between there now, the number of people whose mass lies there. So from 108 to 140, so we'll have 140 minus 108. The number of people, 140 minus 108 is 32. 32 individuals. All right. We are told again to find from the graph the lower quartile. Remember, the lower quartile is Q1, which is usually given by a quarter of the total, which is a quarter of 200, and this is 50. So the 50th person has what mass? That will be our lower quartile, the 50th person. So the 50th person is going to be between 40 and 60. So the 50th person is going to be here, and the 50th person will have a given mass according to this graph. Let us observe keenly the mass we shall obtain. Therefore, we cut the graph at that point, and now we get down to see the number of, or the mass. So I'm actualizing a mass of, remember this is 59.5, so 60.5, 61.5. This could have been 62, but now that we are adding half, instead of 61.5 we have exactly 62. So exactly at 62 is where I'm finding my Q1, 62 kgs. So Q1, 62. Then upper quartile, Q3, is 3/4 of the data. So 3/4 of 200. 3/4 of 200 is going to be 150, yeah? 150th person is the one who carries what we call the Q3, the upper quartile. So 150th person, the 150th person, is going to be between 140 and 160. So that person is going to have the following mass. Let me access it. Again, I use my graph. I draw a straight line. So straight line like that. Then now I go down now to the other axis so that I may know the mass. So the mass is going to be, remember this is 74.5, 75, 74.5, 75, 76, 77.5, 77.5 kilograms. Therefore, to calculate what we call interquartile range, we just need to subtract Q3 minus Q1. So this is going to be 77.5 minus 62. 77.5 minus 62. This will give us 15.5 kilograms as the interquartile range.